Hello students, welcome to this session on random variables and probability distribution. So before everything else, we have here our learning competencies in which you need to exhibit this after this session. So number one, you should be able to illustrate random variables. Number two, you should be able to distinguish between a discrete and continuous random variable. You should be able also to find the possible values of a random variable. And finally, you should be able to illustrate a probability distribution for a discrete random variable and its properties. So we are going to do this four, and then afterwards you will be given tasks to do. Okay, let us start by doing a review on the basic concepts under probability. First, we have our definition of probability from Oxford Languages. So it says here that probability is the extent to which something is probable. It is the likelihood of something happening or being the case. In other books, you can find there that probability are about chances. So what is a chance that this thing is going to happen? Or what is the chance or what is the probability that it is going to rain this afternoon or tomorrow? So those are examples of probabilities. We have here a formula for simple probabilities. It says here that it is the number of outcomes in which the event occurs over the total number of possible outcomes. To further illustrate this one, we have here a problem. In a box of 50 balls, 24 are red, 16 are green, and 10 are blue. If a ball is chosen at random, find the probability that the ball is A. Green. So, from our formula, it is the number of outcomes in which the event occurs. So that is the numerator. So from our problem, we can see here that there are 16 green balls inside the box. So our numerator is 16. And in total, there are 50 balls inside the box. So our denominator is 50. So we have here 16 divided by 50, or that can be reduced to 8 over 25. Or if you would like to put it in a decimal form, you can simply divide 8 divided by 25, or it can also be written in a percentage form. Letter B, find the probability that the ball is red. Again, there are 24 red balls inside the box. So we have here 24 divided by, in total there are 50. So 24 over 50, that will become 12 over 25. And finally, find the probability that the ball is blue. So there are 10 blue balls inside the box. So we have here 10 in the numerator. And then finally, we have 50 balls in total. So that is 10 over 50, which can be simplified into 1 over 5. Now, there are two types of random variables. We have your discrete and continuous. So we are going to differentiate the two. Number one, a discrete random variable is one which may take on only a countable number of distinct values such as 0, 1, 2, 3, and 4, and so on. So discrete random variables are usually but not necessarily counts. So when we talk about random variables, we're answering the question, how many? Okay. And for discrete random variables, the possible answers are counting numbers which are 1, 2, 3, and 4, and including 0. So this is and so on. So it can be 5, 6, 7, 8, 9, 10, and so on. So we're just counting, or they are countables, I mean. Next, a continuous random variable is one which takes an infinite number of possible values. So continuous random variables are usually measurements. As compared to discrete random variable, continuous random variables are measurable. Okay, so most of the time we're asking the question how much for continuous random variables. Examples: the depth of the sea at a randomly chosen point. So we're talking about distance. So do we count the distance or we measure the distance? Basically, we measure the distance. So that is continuous random variable. And distance could be 10.1 kilometers, right? And we have told a while ago that discrete only takes whole numbers. Next. So the depth of the sea, this is continuous. That's letter C. Next. The number of text messages received by Toyota service maintenance crew in an hour. So for example number 2, do we count text messages or do we measure text messages? Obviously, we count. So that is discrete. They are countable. And we do not say that the number of text messages is 3.5. There is no such thing as 3.5 text messages, right? So we're only referring to 3 text messages, 4 text messages. Next, the number of attempts a dart player can hit a target. Same with the number of text messages, we count the number of attempts. We do not measure them. So this is discrete. Or if we are going to use these terms, how many and how much, we say how many attempts. We do not say how much attempt. Next, the price of mobile phones in the market. Okay, do we say how many is the price of that mobile phone? Or we say how much is the price of that mobile phone? So since we're talking about how much or we measure the price, this is continuous. We do not count the price of mobile phones. And then we also have here the number of students to graduate from senior high school. Again, for students, we count students. So this is discrete. We do not measure students, right? We count them. How many of you are going to graduate? So that is discrete. And then we have here the time taken for an athlete to run a mile. Do we count the time or do we measure time? Okay, so we measure. This means that this is continuous. Okay, so take note of the difference between discrete and continuous. Discrete is countable and continuous is measurable. Okay, so we now move on with discrete random probability distribution. So by definition, we have here that the probability distribution of a discrete random variable x is a list of all possible values that x can take and the associated probabilities. So basically, a probability distribution is a table, or it looks like a table, wherein it contains x. Okay, so these are the possible values, or this is the discrete random variable, and opposite it is the corresponding probability. So for example, we have here p of x. Okay, so that means that it is a probability of x. So for x, it can have the values like 0, 1, and 2, and so on. So p of x means that p of 0, that means the probability that 0 will occur. This can be 1 over 4 or any, right? And the probability of 1 can be 1/2, like that. So basically, this is how a probability distribution look like. We have here some properties of probability which we need to take note. So suppose a random variable x may take k different values with a probability that x is equal to x sub I. That should be x sub I. Defined to be p, or the probability that x is equal to x sub I is equal to p sub I. The probabilities must satisfy the following. Number 1, p sub I is less than or equal to 1 but greater than or equal to 0. This simply means that the probability of an event occurring is only between 0 and 1. So you do not say that the probability is equal to 5. There's no such thing as like that, okay? 5% pwede pa. Because 5% is equal to 0.05. So that is still between 0 to 1. And the second property is P1 or P sub 1 plus P sub 2 plus P sub 3 plus dot 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 plus P sub k is equal to 1. This means that the sum of all the probabilities of x is equal to 1. Okay. So if we add the probability of 0 until the probability of k, that should be equal to 1. To further understand random variables and the probability distribution, we have here some problems. Let's start with the first problem. A coin is tossed twice. Let x be the number of heads observed in tossing the coin. Construct a probability distribution of the random variable x. So our random variable here, or our random variable x, is the number of heads observed in tossing the coin twice. First, what are the possible outcomes of tossing the coin twice? We have here a table to illustrate that one. Coin 1 means the first toss. Coin 2 means the second toss. We have here the outcomes and x. Okay, let's start with this number of outcomes. So it says here that for the first toss, the coin is ahead. When you toss it again, it's still ahead. So the outcome is both are heads, so H, H. Okay? Next, it can also be possible that for the first toss, it is head, but for the second toss, it is tail. So that is head, tail. Next, it can also be possible that for the first toss, you got a tail, and then for the second toss, you got a head. So that is TH. Or it could also be possible that for the first one, you get a tail. For the second one, you still get a tail, so that is T and T. Okay, so these are the possible outcomes of tossing the coin twice. Next, we need to find our x. It says here that our x, or our random variable x, is the number of heads observed in tossing the coin. Okay, for the first outcome, we have your HH. How many heads popped out? So we have 2 heads because H here is represented by head. Head is represented by H. So we have here 2H, so we have here 2 for x. Next, HT, we got there 1 head. Okay. Next, for TH, still we got there 1 head. And for the TT, we got there no H, so that is 0. So what are the possible outcomes here based from our table? It is possible that there are no heads, so that is 0. It's also possible that only 1 head will occur, so we have 1. And it is also possible that for both the toss, we got there 2 heads. So we have 0, 1, and 2 as the values of our random variable x. Okay, after that, we are going to construct a frequency distribution. So for our frequency distribution, we have here x and f, or frequency. Again, our x here in our frequency distribution should be the same as our x in our possible outcomes here in our first table. So again, 0, 1, 2. Nanggaling ang mga ito dito sa ating last column, dito sa possible outcomes. May 0, 1, and 2. Hindi lang to randomly generated, okay? Nanggaling ito sa taas. So 0, 1, and 2. Frequency means ilang beses nangyari yung 0 sa ating experiment. Kung titingnan natin sa ating table, isang 0 lang yung lumabas, o isang beses lang lumabas si 0. Therefore, our frequency for 0 is 1. Okay? So we got there 1. Next, if x is equal to 1, based from our table, 1 came out twice, or 2 times na may 1 dito. So there are 2. Okay? And finally, 2. For our random variable x, 2, frequency niya is isang beses lang siya lumabas, diba? So isang beses lang dito. That's why we have 1, 2, 1 as the frequencies of 0, 1, and 2, respectively. And if we get the sum of the frequencies, 4, which means that There are 4 possible outcomes. Okay, next, compute the probability of each outcome. We all have already tried computing probabilities of events a while ago, and we still apply the same concept. Okay, we have here the probability of x. So p of x, let's start with 0. Probability of 0 is equal to 1/4 or 0.25. Saan nanggaling yon? Okay, our frequency is 1 for 0. So 1, kaya yung numerator natin ay 1. Okay? Ang ating sum ay 4. Kaya yung denominator natin dito ay 4. So that is 1 over the sum, which is 4, which is also equal to 0.25 if you're going to prefer the decimal form. Next, number 1, P of 1, the probability that x is equal to 1 is 2 over 4. Again, saan ang galing? Itong frequency niya, which is 2, divided by the sum, which is 4. So 2 over 4 or 1/2 or 0.50. Same lang mga yan. And then finally, the P of 2 is also 1 frequency. So 1 divided by 4, which is the sum. So we got there 0.25. Sabi natin kanina that the sum of the probabilities should be equal to 1. So let us check. 0.25 plus 0.5 plus 0.25, that is equal to 1. Therefore, tama yung ating sagot. Okay, so for probability distribution, we also have what we call as the relative frequency histogram. So if we are going to construct the relative frequency histogram of our probability distribution, it should look like this. Itong nasa baba. Now, paano natin ito ginawa? On the x-axis of our histogram is x, or the number of heads observed. So ito galing yan sa ating x column. For our relative frequency, galing naman ito sa ating p of x. Okay, so we just match them. So we have here 0. If for p of 0 or probability of x is equal to 0, ito yun, our corresponding probability is 0.25. That's why yung ating bar hanggang 0.25, okay? P of 1 or the probability that x is equal to 1 has 0.50 probability. Kaya under 1 hanggang 0.50 and then same with 2. Okay, remember for relative frequency histogram, on the x-axis is the number of heads, x, our random variable x. And then for our relative frequency, that is on our y-axis. The relative frequency or p of x. Okay, let us have our second problem. It is a survey about mobile ownership reports that 96% of the surveyed individuals own at least one mobile phone. Of these, 40% own 2 mobile phones, 25% own 3 mobile phones, 5% own 4, and no one own 5 or more. So let X be the number of mobile phones owned by an individual. Construct a probability distribution. So our random variable here is the number of mobile phones owned by an individual. Before proceed with the probability distribution, let us first analyze our problem. So it says here that a survey about mobile ownership reports that 96% of the surveyed individuals own at least one mobile phone. Ibig sabihin kasi ng percent class, kada 100, no? So pag may 100 daw na individual or 100 individuals, 96 sa kanila ang may cellphone. So 96 here, we have here 96 has cell phones, or check ko na lang yon. And then syempre, ilan yung walang cellphone? Basically may 4 na walang cellphone. So ganun yung situation natin dito, no? And then of this 96 daw, itong 96 natin dito sa taas, 40% ang may dalawang cellphone. So of this 96, 40%, and same with 3, same with 4, and same with 5. Okay, let us first construct a frequency distribution. Our frequency distribution has these random variable x, which can be equal to 0, 1, 2, 3, 4, and 5. Saan ako yung mga 0, 1, and so on na yun? Yung 0, ibig sabihin sila yung mga walang cellphone. Yung 1, sila yung may isang cellphone. Yung 2, sila yung may dalawa. Yung 3, sila yung may tatlo, and so on. So, doon nanggaling yung ating x values. Bakit walang 5, 6, 7, 8, 9, 10 na separate? Kasi according to our problem, 5 or more yung nagawa. 5 or more yung nilagay. Kaya, ganyan. Next, we're going to construct their frequency. Ito, from our first illustration, itong nasa taas. Sa 100, may 4 na walang cellphone. So, pag iti-table natin, x is 0 or no cellphone, may 4. Okay? Next, ilan yung may isang cellphone? Wala pa, no? According to our problem here, 40% own 2 mobile phones. So, unahin muna natin yung 40% na may dalawang cellphone. Balikan na lang natin itong 1 mamaya. Okay, for 2 mobile phones, 40% of that 96 na may cellphone, dalawa ang kanilang cellphone. Yes. Kaya 40% of 96 is equal to 38.4. Saan ulit nanggaling yung 96? Ito, from our first statement, no? That 96% of the individuals own at least one mobile phone. Next, 25% own 3 mobile phones. So, 25% of 96 is equal to 24. Kasi 96 lang yung may cellphone, no? Same. And then, 5% own mobile phones. So, if we get the 5% of 96 is equal to 4.8. And finally, 5 or more mobile phones are owned by none. Kaya 0 yung ating frequency for 5 and above. Ngayon, paano natin makukuha si 1? Dito sa ating table may 30%, no? Pero saan galing yung 30%? Siyempre, i-add natin. Dapat, lahat-lahat ng ito, 100%, yung from 1, at least 1, no? So, 40 plus 25, that is equal to 65, plus 5 is equal to 70. Ibig sabihin, may kulang pa na 30% ng 96. So, yun yung pupunta sa ating 1. Okay? So, we have here for those who own one mobile phone, 30% of 96, that is equal to 28.8. Doon nang galing yung ating mga frequency. For a total of 100 surveyed individuals. Next, we are going to compute the probability of each outcome. So same concept tayo or same solution for computing the probability, the frequency divided by the total. So we have here for P of 0, 4 is the frequency divided by 100, the total. So may 0.04 tayo. For 1, 28.8 divided by 100, kaya may 0.288. 38.4 divided by 100, kaya may 0.384. 24 divided by 100, kaya may 0.24, and so on. If we're going to add all these 6 probabilities, we are going to arrive at 1. Kasi nga sabi natin kanina that the sum of the probabilities should be equal to 1. And then finally, we are going to draw or construct the histogram of this random variable. So the same as what we have done a while ago. For the x-axis, we have our random variable x. Kaya may 0 until 5 and above. So yun yung nilagay natin dito. Yung 5 and above yung ibig sabihin yan, no? And then for our y-axis, we have our relative frequency, which is p of x. Hindi yung frequency, no? Relative frequency is this one, p of x. Kaya for 0, may 0.04 tayo, and so on. So we just draw bars until kung saan ba yung kanyang probability. For 3 here, say for example, may 0.24. That's why in our histogram, under 3, nag-draw tayo ng bar before 0.25. Kasi 0.24 siya. And for 5, since 0 yan, walang bar, no, na na-draw. That is 0. Okay, let us have our last problem. At a school fair, there is a spinner with 12 equal sectors. If you spin the spinner and lands on a specific sector, the number on that sector corresponds to the number of takes you will, or tokens, sorry, you will win. What is the probability distribution of X? The number of tokens you will win. So, basing from our problem, our random variable is the number of tokens that we will win. So, ito yung ating spinner, no? And itong mga numbers, these represents the number of tokens. So 1 means 1 token, 2 means 2 tokens, 3 means 3 tokens, and so on. So what are our possible outcomes? Ito 0, 1, 2, 3, and 4. These are our possible X values. So we are going to construct a frequency distribution. We have here our random variable X, and its possible outcomes are 0, 1, 2, 3, 4. Bakit walang 5? Sa ating spinner, walang 5, no? Bakit walang 6? Siyempre, walang 6 sa ating spinner. Next, we're going to count the frequency of this. Saan nanggaling yung 4, 3, 2, 2, and 1 na ito? Let us see. From our spinner, ilan ang possible na zeros? Or ilan yung may zero dyan? So, pagbilangin natin, 1, 2, 3, 4. May 4 na zero sa ating spinner, kaya 4 ang ating frequency dyan. If X is equal to 1, our frequency is 3 kasi may tatlong 1. 1, 2, and 3. Ang 2, may dalawa. So, may dalawang 2, 1, 2. Kaya 2 yung ating frequency. Same with 3. May dalawang 3 rin dyan. 1, 2. Kaya may 2. And may nag-iisang 4 na 4 tokens. Kaya that is 4. Mag-isa lang niya kaya may 1. For a total of 12 possible outcomes. Kasi 12 equal sectors yung ating spinner. Compute the probability of each outcome. So the same step, we divide the frequency and the total frequencies. So for P of 0, or that is probability of getting a 0, that is 4, its corresponding frequency divided by the total, which is 12. So 4 over 12 is 0.333 and so on. Same with 1, 3 divided by 12, that is 0.25. 2 divided by 12, that is 0.1666 and so on. 2 divided by 12 for 3, that is 0.16666, same with 2. And then for 4, we have 1 over 12, that is 0.08333 and so on. If we're going to add these ones, that is very close to 1, that is 0.99. And it will round up to 1. Kaya equal to 1 pa rin yung ating probabilities. And then if we're going to draw the probability distribution of X, or I mean the histogram, the number of X, the number of tokens one can win. Again, in our X-axis, that is the X values. So yung 0, 1, 2, 3, 4 galing sa ating X column. And then for the Y-axis, ito yung mga relative frequency or yung ating P of X. So for 0, we have there 0.33. Kaya ganito yung kanyang itsura, no? For 4, ito 1, yung pinakamababa, 0.08. Kaya, siya yung pinakamababang bar. Okay, so before discussing your additional activities, you just remember your how to draw or how to construct the probability distribution of a random variable. Number 1, parang kanina, you should know the outcomes. Number 2, you should know the frequency distribution. And then number 3, you're going to compute for the probability distribution. Okay. On the additional activities in your module, ito yung nakalagay na problem, no? Conduct an experiment on the following random variables by interviewing 30 households in your community. Make a summary of your findings by constructing a frequency distribution and a probability distribution for each of the random variables. Ngayon, ang problema, what if wala kayong households or wala kayong dogs or walang dog yung mga household niyo, nagbo-boarding ka, syempre mga konti lang yung may aso dyan, no? You can substitute dogs. So, if you think gadgets, or if you like cell phones, or if you like cats, ano pa? If you like signature bags, or whatever, yun na lang yung ilagay ninyo, no? As long as sa inyong title, palitan nyo rin. Huwag dogs yung ilagay ninyo. Okay? So, kahit ano na lang. Gusto nyo na siya dogs. And, one more thing, if you do not have as much as 30 households, pag isolated kayo, then pwedeng lower, but at least, but not lower than 10 naman sana. No? Okay, so ang gagawin nyo dito ay frequency distribution. Same yung ginagawa natin kanina. So, yung x natin ay the number of dogs. So, for example, so yung mga x ninyo dito, 0 dog, ano pa, 1 dog, 2 dogs, 3 dogs, and so on. Halimbawa, so ang gagawin natin sa frequency, ilan yung may walang aso? Halimbawa, 3 sila. So, ilagay nyo doon 3. Ilan yung may isang aso? Siguro sabihin natin 5. Ilan yung may 3 and so on. So, ganun yung gawin ninyo, no? And then for probability distribution, syempre, you should get here the total para makuha niyo yung probability. So, this is the total or the sum. So, you add, pag 30 yung interview ninyo, dapat 30 yung andyan. And then you simply divide, no? The frequency of that corresponding value of x divided by the total so that you will be able to get the probability. And of course, you should also construct the histogram. If you have any questions, feel free to message me on through my mobile phone, through SMS or through my messenger account. And again, reminding you, enjoy your modular learning and happy learning. I'll see you again next session.